In this lesson, we'll be talking about how to draw Lewis structures or Lewis stack diagrams. Before we get to Lewis structures, we have some vocab to talk about. So first, I've mentioned this before, but we haven't wrote down a definition of valence electrons. Valence electrons are electrons in the outermost energy level. So when we draw our Bohr diagram or we write our electron configuration, the electrons that are in the outermost energy level farthest from the nucleus are the valence electrons. The octet rule. So oct meaning 8, like an octagon, it has 8 sides. The octet rule states that atoms will gain or lose electrons to have 8 valence electrons. Why is 8 the magic number? We want full S and P orbitals. So neon is an example of an atom that has 8 valence electrons. The electron configuration for neon is 1s2, 2s2, 2p6. So again, valence electrons are in the outermost energy level. The second energy level is outermost. And its s orbital is full. S orbitals can only hold 2 electrons. P orbitals can hold 6 electrons. The P is full with 6 electrons. So this is an atom that has 8 valence electrons. So the reason that an atom ionizes is so it will have 8 valence electrons. All atoms want to follow the octet rule. So let's say we had fluorine. Let's say fluorine has 9 protons, 9 neutrons. So as an atom, fluorine also has 9 electrons. We know the first energy level can hold 2 electrons, 3, 4, 5, 6, 7, 8, 9. So again, valence electrons are in the outermost energy level. For fluorine, it would be the second energy level, and there are 1, 2, 3, 4, 5, 6, 7. So fluorine gains 1 electron. That's why fluorine always has a charge of -1. The reason that fluorine always gains 1 electron is because it has 7 valence electrons. It needs to follow the octet rule. It wants 8 electrons. Let's look at a positive ion. Let's look at something like sodium. So sodium is atomic number 11. So it has 11 protons, 11 electrons. So with sodium, it only has 1 valence electron. Again, valence electrons are in the outermost energy level. But it doesn't make sense for sodium to gain 7 electrons. That would take too much energy. So instead, sodium can lose an electron. Sodium loses 1 electron. If sodium loses 1 electron, its charge is going to be +1. Well, what happens when sodium loses that electron, it loses that entire energy level. So what sodium looks like now is its first energy level has 2 electrons. Its second energy level has 8 electrons. And it lost the third energy level. So when sodium loses 1 electron, it now has 8 valence electrons, and it follows the octet level. Last new vocab term before we start drawing some Lewis structures is isoelectric. Isoelectric is when 2 species have the same electron configurations. So the fluorine ion and the sodium ion would be isoelectric. So when fluorine gains an electron, it now has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Its electron configuration would be 1s2, 2s2, 2p6. Well, sodium as an atom has 11 electrons. If it loses 1, it has 10. The neon atom also has 10 electrons. So these 3 species would all have these same electron configurations, so they are considered isoelectric. A tip for figuring out the number of valence electrons that an atom has. We can draw out Bohr diagrams and we can figure out the number of valence electrons, but the easy way to remember it is the number of valence electrons will be equal to the main group number on the periodic table. So everything in group 1A has 1 valence electron. Every atom in group 2 has 2 valence electrons. We're going to skip the D block. Everything in group 3A has 3 valence electrons. 4A has 4, 5, 6, 7, and 8. Helium is the only exception. Helium has 2 valence electrons. So keeping all that in mind, let's start drawing some Lewis structures, or Lewis dot diagrams. So why do we draw Lewis structures rather than Bohr diagrams? So the Lewis structure just shows the number of valence electrons. And again, we drew this on our periodic table, but just so we have it in our notes, again, the number of valence electrons is equal to the main group number on the periodic table. When we are drawing Lewis structures, each dot represents one valence electron. So let's look at our steps. These are pretty easy to draw. Step 1. Write the element symbol. Step 2. Determine the number of valence electrons. Step 3. Place one dot on each side of the element symbol until all dots have been placed. Really important for step 3. When we are placing our valence electrons, we do not pair until all 4 sides have one electron or one dot. Alright, so let's do 3 examples. Again, these are pretty easy to do. First one, nitrogen. So step 1, we're going to write the symbol. Step 2, determine the number of valence electrons. So I'm going to find nitrogen on the periodic table. Nitrogen has 5 valence electrons. Step 3, place one dot on each side of the element symbol until all dots have been placed. But we do not want to pair until all 4 sides have one dot. So 1, 2, 3, 4. Once all 4 sides have one dot, then we can go back and pair up. Something like this, 1, 2, 3, 4, 5, would be incorrect. So make sure you remember one dot on each side before we're allowed to pair. Aluminum. Finding aluminum on the periodic table. Aluminum is in group 3A, so it has 3 valence electrons. We write the element symbol, one dot on each side before they can pair. So aluminum should have 3 solo dots. And the last one, selenium, group 6A, so 6 valence electrons. One, 2, 3, 4. Once there's one dot on each of the 4 sides, we can go back and pair. It does not matter where the pairs are as long as you have 2 pairs of electrons and 2 solo electrons. So those were all for atoms. Let's look at Lewis structures of ions. Metals typically lose electrons. So aluminum is a metal. Aluminum would lose all 1, 2, 3 of its valence electrons. Well, if it loses 3 valence electrons, your metal ion would have 0 dots. Nonmetals tend to gain electrons. And again, we want to follow the octet rule. Nonmetals should have 8 dots. Nitrogen as an atom only has 5 valence electrons. When nitrogen ionizes, it's going to gain 3 electrons because, again, it wants 8 valence electrons and wants to follow the octet rule. So it's going to gain 1, 2, 3 electrons, giving it a total of 8 dots. Lastly, if you are drawing a Lewis structure for an ion, ions go in brackets with the charge outside the brackets. So let's do the nitrogen ion, the aluminum ion, and the selenium ion. So nitrogen, we said, as an atom, it's in group 5, so it has 5 valence electrons. If its charge is 3 minus, that means it gained 1, 2, 3 electrons. And if it gains 3 electrons and electrons are negative, that's where that 3 minus charge comes from. Let's do selenium next. We said selenium is in group 6. It has 6 valence electrons. It wants to follow the octet rule, so it's going to gain 1, 2 electrons. If it gains 2 electrons and electrons are negative, its charge is 2 minus. So the reason that atoms ionize, the reason that nitrogen always gains 3 electrons is because it wants to follow the octet rule. Selenium has 6 valence electrons. To follow the octet rule, it needs to gain 2. So very easily we can see of looking at these Lewis structures, each of these ions is following the octet rule. The metals look a little different. Aluminum is going to lose its 3 valence electrons and it has a charge of 3+. But looking at this, aluminum doesn't have any dots, or it doesn't have any valence electrons. Well, I thought everything needed to have 8. Well, why does that happen? Remember that this happens because it loses its outermost energy level. So if we were to switch to a Bohr diagram, aluminum starts with 13 total electrons. When aluminum ionizes, it's going to lose 1, 2, 3 electrons. That means it loses the entire 3rd energy level. So now the 2nd energy level becomes outermost, and we have 1, 2, 3, 4, 5, 6, 7, 8. So the metals are still following the octet rule, even though our Lewis structure is not showing any electrons.